at Intel. They're also in our group. They developed a fuzzer TSFFS, which enables snapshot fuzzing in a CIMIX environment and is really great for a number of use cases. So hopefully, these two tools will give kind of a suite of things to support various fuzzing needs. I've included the GitHub link there. My background is in vulnerability research, reverse engineering of software and hardware for a number of years. I've been with Intel specifically for the last 2 years and covering a number of things, security research, development of tools to support things, including this effort here for supporting fuzzing UEFI, as well as things across the board up to even cloud security. So organization of the talk. So we'll touch on motivation very briefly. We'll touch on background, talk about our motivation, what we did, what's kind of in the current workflow, what does it look like to use this tool, what's there. Then we'll talk about some fuzzing efforts that we have done and have underway, as well as time permits, we can do a little bit of demo if people want to see fuzzers run or things like that, some of the output. So importantly, motivation. I think everyone here is pretty motivated. The core things here, I took a few quotes from a couple of the UEFI forums that are included in the references there. And really, it's part of a suite of things that you want to do to test the code that you're doing. And in addition to unit testing, if you were to pick one, unit testing or fuzz testing, the answer is pick both. You really should do both. And that's acknowledging fuzzing can be often very challenging in terms of developing a harness, operating it, and triaging crashes and so forth. So our goal here with this tool is to help lower the bar, make it easier, and help you ideally get it into your CI/CD process so things are automated. So importantly, background on HBFA. This was originally released. It was really a proof of concept. It was released back in 2019. There's a white paper associated with it, describes some of the capabilities there. And it was hosted on EDK2 staging, so it hadn't got folded into EDK2 proper. And again, this is the basis. This is where we started, what we started with. And it covered a number of capabilities, including supporting FL, libfuzzer, Peach, as well as some additional fault injection, use of CLE to support if you want to maybe develop a seed corpus to reach a particular function and state. It could help support that, as well as some unit fuzz tests in other cases. We've removed some things. Some things we'll hope to add back in time, but we wanted to really minimize the set and be focused about what we're doing. So this can be something people can use quickly and in their CI/CD. So again, this whole thing started in our group, at least, is we need across the company to have fuzzing done, and we needed to develop several different tools to support that process. And this was one tool in the tool set that could be very helpful, and we wanted to automate as much as possible. So that includes, the fuzzing session, as well as, getting code coverage reports and getting that information out. When we started looking at HBFA, the release that had went out to EDK2 staging, a lot of things, you had to install everything piecemeal. You had to go through some text documents, and a lot of things were somewhat out of date at the time. And again, it was a kind of a sandbox prototype thing that was released to the community, in the hopes that that would be developed further. And we saw that, and we're like, okay, we want to pick this up and move it forward, update it, make it better. We wanted to really, get it to work with everything modern, so it could be in a modern, Fedora or Ubuntu or other type environment, and use the latest Clang, LLVM, as well as anything else for that matter. So the prior version of HBFA had a simplistic WX widget GUI, and it had Windows support and some other things. We removed that from what we're doing because, again, we really need to focus. Let's get this to work reliably in a Linux environment with modern toolage, modern approaches for coverage, data on our fuzzing, as well as sanitizers. And we were focused on AFL and libfuzzer-based fuzzing out of the gate. And our hopes was we could our goals at the beginning was, we want to be able to get this out to the community. And if we can get it out to the community too, hopefully we can get this to something like OSS Fuzz and help support large-scale fuzzing of such a critical piece of software. So our current efforts right now, of course, we work with latest versions of Clang, libfuzzer. We were able to add in prior. They had some support for ASON, but that was everything was enabled, and we were able to. We've got pretty much good granularity exposure for IMSON and a number of the UBSON undefined behavior test, as well as we added additional enabling. So instead of just GCOV, LCOV based reporting for your coverage data, you can also use ProfRaw, the LLVM tool chain output, and generate those reports. A number of the unit test cases originally, there was drift in the EDK2 code base. There were some other issues that we identified, memory leaks and other things, and we had some help early on from the prior authors, as well as throughout this process and to the release and actually ongoing. We've been fixing a number of issues with some of the test cases and other things. So try to get this where this could be leveraged again in OSS Fuzz. Very importantly here, we really wanted to spend a lot of time on getting at least a good picture of the documentation and training so people can leverage this out of the gate. And that kind of covers a range of things from, setting up your environment in Linux, conveniences to set up that you need for environment variable factors to make things play nice, and likewise for generating the code coverage and reports and those sorts of things. So again, a lot of this is documented, included in our documentation, how to get up to speed, how to get fuzzing, as well as we have a full tutorial on taking the EDK2 Hello World Dixie driver or example. I think it's an EFI program. Taking that, introducing a vulnerability, stepping through that, and developing a fuzzing harness for it, fuzzing it, and then finding the bug via fuzzing and triaging, debugging in the whole 9 yards. So it's relatively straightforward to get all of this in a container and be able to do all of that from a single environment. So next couple slides, we're going to step through, okay, what do you need to, what does the workflow look like? What do you need to actually do this, to actually use this? And the first thing you need is, you need to set up the environment. You need an EDK2 environment, and you need HBFA there as well. And you need that to play together and work. And there's a couple approaches. Again, our documentation has a pretty straightforward set of instructions that'll take you all the way through the process for doing that. If you want to set up on your own independent system or something that's different. An easy approach that works really nice. You can see on the right, I'm sure the text is way too small. I would say look at our source code because it's in the workflow file, and you can see that. That'll get you pretty close. This is our daily build test to ensure all our test cases build. And basically it builds that environment. And we leverage this first easy approach, which is use Tiano Core's containers that they use for EDK2 development. They have support, they have various Ubuntu images, they have Fedora images, and I think a few others as well. I know I've definitely used both Fedora and Ubuntu without issues, and it works nicely. So again, like the workflow on the right, we integrate that, we use that, and then we build a few things on top of that, not much, and you're ready to go, at least ready to build the test cases. And again, you see the instructions, it's not too bad to get everything else rolling. So again, the second is, okay, once you've got this environment set up, now you need to think about your fuzzing harness, right? You're either going to have to write your own fuzzing harness to call libraries that you want to test, or you're going to maybe one of the ones we have is really close to what that's included is really close to what you want to do, or at least you could look at that as an instruction. If you just want to test fuzzing and understand this whole workflow, you can go ahead and use one of those out of the box as well. For those, you can see we have some of our documentation will tell you all of the fuzzing testing cases available. You can see on the slide, you'll see the list of, I think, about 16 that we have currently supported. There's also a list in there of the ones that we don't have supported at the moment. Some you may see start to come back online as soon as we get fixes. Additionally, you need your fuzzing test harness, and you will need your seed corpus. Included with this for all of the test cases are the seed corpus. And we point out the locations where you can access those. You need to reference those when you want to actually run the fuzzing, which we'll show soon. If you instead are developing your own fuzzing harness, which is the most likely case, again, we have a full walkthrough from Hello World, adding a bug, and writing the harness for it in our documentation that will hopefully help you get up and running quickly. The core important parts, if you're familiar with developing fuzzing harnesses for libfuzzer, usually you'll have to kind of a call loop where it's like run fuzz, and you're going to set up a state and get a buffer from the fuzzer, and then you're going to create some state that maybe you need to call into one of your library files. Here in this, the screen caps on the right side, the left one shows just a simple fuzzing harness for a function translate BMP to GOP BLT. And simply here we've set up state, and we receive the test buffer from our fuzzer, and basically we will create the state and then call the function, and that loop will iterate over and over with the fuzzer being used, whether it be AFL or libfuzzer. There's a couple other things there noted: fixed buffer and get max buffer size. Get max buffer size is obviously limit what size buffer you're getting back to feed to your target, and fixed buffer if you need to make some touch-ups to your buffer, set certain bits such that it's going to pass a certain check or test or thing needed for the state. That gives you a last call before you call your function to touch those things. So again, see the documentation. It pretty much walks you through the whole process there. So we have our environment. Now we have our fuzzing test harness and our seed corpus. So now we're going to try to call, we want to run the fuzzer. Before we can use our module, though, we need to build it. And you can use the EDK2 build system just as normal. The key important things here to note are that you're going to use a platform. This is the main part of what HBFA is. It's instead of calling a specific board in EDK2 for a platform, you are calling your UEFI host fuzz test case package, which is included in HBFA-FL, and that is what's providing the linkage under the hood to AFL and libfuzzer. You will develop your fuzz harness, and that's going to be your module, your test case. Here we were calling into BMP support lib function, so we call it test BMP support lib. So that is our module we're referencing, and of course, architecture supported are currently just x64 and x86. And you'll provide a build target. Here we've included AFL because we're going to run this in this case for AFL. Additionally, we include GCC. That can be used for coverage data. That will also build it with GCC, but with debugging information and everything needed to emit the coverage data that will get later processed. And we provide a configuration, and part of this is in the setup process where you'll copy the configuration over from HBFA-FL into EDK2. So that's all described in the setup process. So basically you can run this, it'll build your test case, and then you just need to run what is built, which will be an ELF binary, and you can run that, of course, userland side on your container, and that will fuzzing will occur. So more convenient than that, though, instead of having to deal with tracking all of this and manually doing it, there are a number of fuzzing scripts to support this whole process and kick off fuzzing automatically. We have a run AFL and we have a run libfuzzer Python script. These do a number of things behind the scenes for you, of course, invoking that build command for EDK2, as well as starting the fuzzing run for you, for example. So for those, it's just a simple pattern. You provide the architecture, you'll point to your test case module for your fuzzing harness, you'll point to your corpus, which you can see on the -i input, and then you'll point where you want your output. And in this case for AFL, it's going to have the traditional AFL output with the crashes folder queue and other information. And basically, if you run this like this, it's going to invoke the fuzzer and things will be off and running for you. So the other, of course, is run libfuzzer. And here you can see an example of run libfuzzer and same prototype for arguments that you would provide to that. Generally speaking, if you develop a module in this framework, and you can fuzz with both AFL or libfuzzer to your preferences. We do have additional sanitizers available with libfuzzer, so that is very nice to take advantage of IMSAN and UBSAN. And yeah, here I've noted there's additional S option. And additionally, since it's LOVM chain, you can get prof raw output if you want coverage data to branches and other like regions So it'll give you a little bit more verbose and additional information on your code coverage. So again, we have built our environment. So we have a running container with HBFA and EDK2. We have identified our fuzzing module or wrote a fuzzing module test harness. We have now built it and we have ran a fuzzing session. When you're done with this, you're now ready to generate, to use a couple of the included HBFA scripts to generate code coverage reports. So you'll run a report main, and this is going to do analysis on whether it be libfuzzer output or AFL output, and it's going to process and determine how many crashes were found and give kind of a simple report of overall what happened in the fuzzing session. And then you'll use gen code coverage to actually process all of your either queued path files that have identified code paths or what came out of LLVM libfuzzer, and it will process through those and generate your code coverage output in HTML and some parts text output. So briefly touching on some of our fuzzing campaigns, we did, as we developed this, we did a couple of fuzzing campaigns to kind of shake things out and test things. And throughout that campaign, we found a couple hundred crashes. We triaged that down to about 12 unique crashes, and we're able to feed part of that back to the original HBFA authors as well as to ourselves to fix some of the testing harnesses and other things. And importantly, we're able to feed some of the bugs back to TNO Core EDK2. 3 were fairly significant security bugs, and there may have actually been another one that was an overlap with one already found, as well as some additional bugs that we reported to them. Since this time, we've been able to actually get this out to OSS Fuzz, and that is operating and finding things that are getting directly reported. So again, this is our repository. Please see there's a lot of good documentation that can hopefully help you get up and running fast. Also, feel free to reach out to me if I can help, answer questions or anything like that. And how are we on time? I can do a quick demo if people want to see.
Yes, please do. I already stole some of your time, so feel free to do it.
Okay, no worries.
Yeah.
Thank you. And then tell me when I need to start breaking.
I guess I don't know. Let's take another 8 minutes for demo, and I guess we should switch to questions because I already have a couple, and I guess there will be other. So yeah.
Okay, sounds great. Thank you. Okay, so first we're going to look at just running a couple an already included fuzzing test modules, so you can see what that looks like. Now, right now we're looking at a console. Is that coming through clear for everyone? Is the text okay, or do I need to get a little bigger?
Yes, it's okay.
It's okay. Perfect. Thank you. Okay, so whenever I started this environment, take note that if you are using AFL, you'll need to run your container as privileged, which you can just specify privileged if need. If not, then just stick with libfuzzer, the run libfuzzer, and you'll work fine with that without having to raise privileges. Part of that is the configuration and setting the CPU affinity and some of the other things. It was just a design decision, but you could always adjust things however you need to for your particular environment that you're in. And okay, so here, so we looked at an example. Okay, oh, I see. Okay, so we looked at an example of this in the slides, and we went through and we looked at the prototype where you specify architecture as well as a few other components. The critical things are your module file for your test harness, as well as your input corpus and where you want your output. One thing to notice here at the bottom, there's an additional mode here where I have what we call raw command and manual. And the design decision was, we want this where if you run it default, it is going to just kick off the fuzzer and it's going to run, even in a non-TTY environment, and things are going to run for you for the fuzzing session. So everything can happen automated. You could set an at time and let it run so long, and then clip and cut it and get your results, right? So it'd be easy to automate from that standpoint. If you want to run it in another mode, we'll call manual, or I think raw command. It's going to generate, manual. It will print a output of what command you should run to start the fuzzer. So it'll build everything for you, get everything ready. All you have to do is run the fuzzer, and it's going to emit the command that you'll run. So relatively straightforward. Let me get a command here. So if we look here, we have run FL. Again, the architecture. We're providing our fuzzing test module, which is the test BMP support lib, and we're giving our input corpus. Again, these are ones included with HBFA-FL, and they're in the tables in the documentation, so it's easy for you to find the relative path to these. And likewise, we're going to put our output from the fuzzing session for AFL to that given directory. And if we go ahead and run that, it's going to be building behind the scenes. Okay, yeah, it went through pretty quickly there. So dry run through test corpus. Let's see if I can capture. Yeah, build successfully, and give some output of what command it ran. So right now, this would be if you didn't have a TTY and you wanted to just let things fuzz. Importantly, I'll show the other mode, which will look a little more familiar. Let's see, before I do that, our output, you'll see a familiar AFL output, crashes, hangs, queue, so forth here, and you can process that with whatever tools that you're comfortable with AFL output. However, we also will show the tools shortly of how we process that, how you can process that with HBFA-FL and get your code coverage data really easy. Before I do that, though, let me clear that folder, and then I'll show you the manual output so you can see the traditional friendly HBFA output, right? Or the traditional friendly AFL output. So if we do manual, again, this is going to build, and then it's just going to emit the command we need to run if we want to initiate the fuzzer. So there we go. And then if you have a TTY and you want to put a bunch of those up, then you'll get the classic display you would expect. So anyways, just a convenience factor. And again, you would see the same thing in the crash output folder. Let's see. The next thing we want to do is look at generating a report. So for a fuzzing report, we have report main, and this is just going to get the high-level statistics for the fuzzing run. And this will work with AFL here. And that will have generated a report now. When we ran this, we said we want to use the build of our test module. That was the GCC build, debug build. This is again in our documentation, but you'll want to point to this instead of the AFL build target. This was automatically built for you behind the scenes when you run AFL. So you point to this, and these are the builds that will emit the coverage data. And what's going to happen, or what happens later when we run this with Gen code coverage, is it's going to step through and run everything from your queue through that to help emit the code coverage data that was covered by the test. And here we provide our input. This is our output file from the fuzzing session. So this is our AFL output data. And again, where do we want to report and the type of material we're dealing with here. So we ran that, and you should see, yeah, a debug report here. And yeah, you'll have a nice index of crashes if there are crashes. Otherwise, it's going to populate to nothing, and a few other things there. If we look, it would be something like this. It'll give you kind of an overall report, and you can drill into some of those. Next, we're going to run the gen code coverage command, and this has a very similar, same kind of prototype as the report gen, and we're going to point it again to our GCC built images of our fuzzing harness, and we're going to point it directly to the queue from our output from AFL to process through all of those and generate coverage data. And behind the scenes, it's going to run through each of those, and then it's going to run LCOV and generate the HTML report. So again, it has stepped through all of those and determined code coverage. And if we take a quick peek, we're going to see kind of the standard LLVM or LCOV, sorry, output. If we take a look at what that looks like, you're going to have a nice line by line and functional coverage percentage breakdown of what you achieved during your fuzzing session. And of course, you're going to see your fuzzing test harness, and you might see things, some of the support libraries or stub functions We have some stub functions in HBFA, included in HBFA. You might see some of those and see what was touched in those, but importantly, you'll want to drill down into your EDK2 code base and see, what your coverage is, because that's what you're really targeting. And again, this is pretty standard LCOV output. So next, let me jump back.
I guess this should be last one, huh?
I'm sorry. Do you still have me?
Yeah, I still have you, but let's make it last one.
Okay, perfect. You know what? We can go ahead and just jump. The next is we can run through this for libfuzzer, and it's very similar prototypes, very similar results. And importantly, I ran it this time with providing IMSON and UBISON and using profile output, and it will do the same thing, run GenCom coverage, and you'll get nice output. So you can chain all of this together readily with just making a couple command calls in your container, and you will get a nice HTML report of your fuzzing session, and of course recover all of your crashes or anything else that is relevant.
Sure.
Yes.
Is that all your slides, or you have something else?
Yeah, that more another time if interesting, or we could do a much longer demo on. This goes through fuzzing, developing a Hello World application and fuzzing that. We also have that in the documentation, thoroughly captured with screenshots and everything. So
okay,
I definitely recommend taking that. But,
yeah, I guess let's switch to topics. We are already quite delayed, and this
yes,
took some time, but it was great presentation. Thank you very much for that, and thank you for joining. If you will be interested in showing us more, I'm especially like fuzzing stuff is important, but I'm not expert in fuzzing, so hard to discuss with the methodology or whatever, data preparation or whatever. But it's very interesting for me from the kind of operational perspective, quality improvement perspective, in terms of maintaining kind of downstream EDK for Dasharo. So we have to think about that.